Hi, let's check out 12.3 Measures of Central Tendency. So first is the mean. We have two types of mean. One is a sample mean, which is a descriptive measure of a sample. It is a sample statistic. And then population mean, a descriptive measure of a population. It's a population parameter. Notice that for sample we have x with a line over it pronounced x bar. Okay, and then mu is a Greek letter pronounced mu. Okay, so the formula for the mean looks pretty similar in both situations. The difference here that we haven't talked about yet is n is number of values. And this is, the top is the sum of all data. Okay, so suppose I sampled 5 of my friends and asked how much money they donate to charitable organizations. Find the mean of their annual giving. So to find the mean, we add these all together. And when we add them up, we should get 15,400. And then we divide by how many there are. 1, 2, 3, 4, 5. So this gives us 3,080 is the mean. What I think is really interesting about the mean is, look at this big old 10,000. That's going to really affect the mean. It's because the mean is not resistant, which we'll talk about in a little bit. Okay. So we're trying to find the center of the data. This is like the average. Importance range values. Oh, a median. Sorry. We moved on. Median is like the middle. Same values. We want to arrange the values smallest to largest. And then find the median. So if we arrange them smallest to largest, and then we find the middle one. 1, 2, 3, 4, 5. So 3. There we go. What if we have, so our median is 1,200. What if you have an even number of values? Find the median. So if we have an even number of values, like this here, we can still put them in order. But 2 and 6 are in the middle now, so I'm going to take the average of them. So our median is 4. Okay, so a number can be a median even if it's not explicitly listed in the set of data. So in interpretation, the median splits the data into 2 equal halves. Halves are, half of the values are below the median and half are above. Sorry, I wrote this backwards. Half of the values are above the median and half are below. Okay. Mode. Mode is the number that occurs most frequently. Okay, so find the mode. Which number happens most frequently in each set of data? So take a moment, find the mode. So the mode has been listed, and notice if there's no one value that is more frequent than another value, then we say there is no mode. It says mode is more commonly used for categorical data. So 3, we have 24 students were asked their favorite singer of all time. The data are below. Find the mode. So who did they say most often? And if I look at this, I could count them up. Ariana Grande. Is the mode, the most common. Okay, mid-range is another way to look at measure of center. Mid-range, we take our lowest value plus the highest value and divide it by 2. So find the mid-range. Our lowest value is 1, our highest value is 11, divided by 2. So we get 6. Find the mid-range here. So lowest is 2, highest is 8. Find the mid-range here. The lowest is 3, the highest is 7. And the annual donations, the lowest was 0, the highest was 10,000. Okay. So number 4, there was a high turnover rate at a new restaurant, Turn Up the Beat. The number of months that the most recent set of employees worked before quitting are recorded below. For this set of data, determine the mean, median, mode, and mid-range. Then list the measures of central tendency from lowest to highest. Okay, we have all the tools we need. Take a minute and try this out. All right, take a minute to check it on your answers. Okay, next is a really long list. This is the 2019 base salaries of the Broncos. So that's all listed out there for you. But we took it and already did stuff with the data, so you don't need to stare at that. So we want to examine the Broncos salary data and measures of central tendency. Which measure of center is the best, and explain your answer. Well, if we look at their data, we can see that some are just much higher than the rest, right? So some are in 17 millions and 18 millions and so on. Whereas if we work our way through, we get down in like the 400,000 range. So the mean is going to include those really high values. The median is going to be in the middle, so that would be a little bit better, I think. The mode is which happens most often, and the mid-range seems like it's really affected by those high values. So the measure I would think is the median. So the median accounts for extreme values. All right, so resistance. This is how resistant a measure is. So if I put in something really high or really low, will it affect it greatly? All right, so let's see where we're at here. Okay, let's take a minute, find what it's asking for, and then we'll talk about resistance. All right, so we have the mean, median, and mode set up for each of these sets of data. Notice the second set has an outlier, which just means a number that's much different than the rest. So this 20 is a lot bigger than 3 and 4. So the measures that stayed close when we had an outlier are the median and the mode, whereas the mean and the mid-range changed. So resistant means that it doesn't change when an outlier is present. So the median and the mode are resistant. The mean and the mid-range are not resistant because they change drastically with an outlier. All right, go ahead and read about percentiles. Okay, so if something is in the 70th percentile, it means that 70% of the data was lower and 30% of the data was greater. We can also look at quartiles. And to find quartiles, we have to divide the data into 4 equal parts. So the second quartile is really your median. So here's between 16 and 19. So 17.5 will be our second quartile. And then we go ahead and find half on each side. No, I didn't count over enough. Okay. Alright, again, if you have questions, concerns, please reach out to me, let me know, let Devin know. I hope that this helped.